Okay, good morning, folks. This is the last lecture that we have, and after my presentation, just to complete the sample problem, I will disappear, but the GAs are going to be here to help you uh, with the lab if there are any questions. Uh, now, between now and the between now and well, I don't know. I suppose August 21st, where your final exam is due, the take-home final exam is due. I will not have any formal office hours, and if you need anything from me, you have to email me first, and then we'll see what we can do. Okay? The GAs are not going to have any office hours either. It's up to them whether they want to reply to any questions that you have. Okay? Excuse me. Uh, well, first of all, are there any questions before I start with the other remaining two problems? Okay. So let's work on this one. Use your own dimensions to model this mechanism. It's a very simple mechanism, by the way. And there is some write-up here. It's important for you to read it, because otherwise it can be tough, because you're trying to make sense out of that. This triangular panel is fixed in space. In other words, yeah, so it's anchored basically at the end. Now, the pipe and this piece, which is rigidly attached to the pipe. In other words, I have a choice. I can make the pipe and this thing as a part of it. That means it's rigidly attached. It's a single part. The pipe and this guy in a single part means essentially they're rigidly attached. Or I can create the pipe separately, create this blue piece separately as a part. And when it comes to joints, this guy is rigidly attached as a joint to the pipe. And that's the approach that I'm going to take. Okay. Some extra work, but I'll do it like that. And then, of course, there is a crank here. This crank is attached to a motor, probably in the background, back behind the triangular panel. It turns, and in it there is a wheel. Okay, and the wheel obviously will roll. You're assuming that the wheels roll unless otherwise specified. By the way, you might say, well, when is it that the wheel is not rolling? Well, I mean, if you slam on the brake and basically the wheels start turning, well, the car is going to slide. Is it slide? Slide, and of course, it's going to be not rolling. All right, that's the situation. All right, let's go ahead. So I'm going to start a product file. Immediately save it. File, save management, save as, desktop, new folder. Let's call it 1111, July, August 6. August 6. Let's make it lab 51. Where is it? Lab 51. First, I'm going to make the panel. So let me go to assembly design, insert, new part, in there, right click, properties. Let me go by the colors here. So let's say that's gray, right? Gray. In gray is like this. Gray. Let's make it. Okay. So on that plate, on that plane, I'm going to sketch a triangle. Doesn't have to be a triangle, but keeps us focused so that we know what we're doing here. So maybe there. Okay. Okay, let me make this thing horizontal. Doesn't have to be, but very good. All right, now I need a little hole here, little circle there. That's where the crank is gonna go. All right, exit, pad it. Make this thing a little bit smaller, 0.3. On that top face, I will sketch something like this. That's where the pipe is going to go into later on. And let me draw another one on the side. Okay, exit, pad it. I'll make this thing 1. Okay, and on that face, I will sketch a circle. That's where the pipe is going to go into. Because I did not take care of keep track of my dimensions, at some point I may have to come and resize some of these things. So this is going to be pocket all the way to the last. There we are. Okay, so the pipe is going to go. That's the gray piece. It's not as elaborate as what's in the handout. Okay, so let's save everything. This really, I should have made it a. This I should have made as a pad instead of a hole, but that's okay. I'll do it. If you had this problem on the test, make it a pad. All right. So insert, new part. Oh, not this. Insert, cancel. Insert, new part in there. No, make it the pipe. Right click, properties. Pipe. Double click on a convenient plane. On that plane, I will sketch. Project that circle. Okay, exit and pad it to get the pipe. Let's see now. Pad. And I'm sure you know what this more is for. If you want to pad it in this direction, yeah, that's good. Let me make this thing a little bit. Who knows? Okay, there we are. So that's the pipe. Now there is a little piece that's going to get rigidly attached to this. Okay, so I decided to do that as a separate entity. We're going to do that right now. So insert, new part. No, I'll call it the blue piece or blue part. Properties, blue. and blue. Okay. Double click on it. Let's see what we got here. So on this face, I will sketch, project that. Okay. Direct view right there. And let me complete that thing. Something that resembles what we have. So, I don't know, maybe like that. As I said, I may have to resize some of these. Definitely, yeah, okay. Probably that's probably one of the pieces that I have to resize and pad it. Let me make it a little bit. Yeah, that's good. That's good. I would like to make this thing longer because the wheel should, depending on the size of the crank, this may have to be a little bit long. Oh, not this way. Oh, I have to go to sketch, right? Longer. Yeah. Exit. Good. And I'll make a pocket here, which is going to be the path of that little wheel that we're going to make. Because this is not thick enough, I may have a hard time drawing the wheel there, but we'll see. Exit. Pocket. Okay, very good. All right. Let's go up there. Save everything. Why don't we insert the wheel first? So insert new part. The wheel that's going to go in that track. That's the yellow wheel, right? Properties. Wheel and wheel. Okay. So let's make it. On that face, I will sketch. Okay, so I'll draw a circle. Remember, this circle must be tangent to that later on, okay? However, right now we don't have to worry about it, so I'll just make it like that. The wheel is, I mean, it should, maybe the way it's drawn, it should be same diameter as that. It doesn't have to be, but here, I'll make it a little bit bigger so that you get the illusion that it is the same, yeah, it is the same diameter. Exit, pad it. Actually, you know what? Why don't I also draw a circle in there so that we can see the a feature there that is rotating when it's rolling. Okay, exit, pad it, and you know, although I don't have to, but I'm going to make it the same length as this. Okay, because for a roll curve, all you need is one curve rolling on the other one. This guy does not have to be the same. This other end does not have to be necessarily on that other edge. But yeah, actually, I'm not going to do that. 0.5. How about that? 0.5. Okay, this does, this does not have to be exactly that. For real life purposes, it probably does, but not for me. Okay, good, good. So this is all done. What else do we need? The crank. That's the only thing that's left. So let's insert new part. This last one is the crank. Right click properties, crank, crank, and crank. Okay, let's make it. Okay, so first fit this thing. Okay. All right. So the crank is going to go in there. That being the case, on that face, I will sketch. Okay, so you know, something that actually, you know what? First of all, let me project that circle instead of a hole in the crank. I'll make a shaft in the crank so that at least it looks reasonable when it comes to drawing. Okay, how about I don't know. You know what? I'm too lazy. So all right, that's better. Okay, what do we got here? The wheel is going to go there, right? So let's do this. I can't even remember. How did I do my wheel? Yeah. You see, in principle, either you have to have a hole here or a shaft there. But you know, I'm not doing a good job. I'm just showing you the fundamentals. I suggest that for the test, for the final, you draw these as reasonably as possible. In case the problem is not working, at least give us a reason to give you some part marks. Okay. If everything looks different and it doesn't work, then what do we have to do? Okay, so exit. All right, so let's make a multi-path here because I want a shaft there. Okay, so should be 3 curves here. Why do I have 2? Oh, that's because maybe that's not closed there. I can see that. You go here, you go to that sketch. I don't think it's closed. And you can always clean it up yourself, or you can go to Tools, Sketch Analysis, and any closed curve that you see there, close it. Okay. Now, if I do multiplat, probably you'll see 3 curves. Yep. So this is a big one. For now, let me make it, I don't know, 0.1. I have no idea. 0.2. Okay, this guy is the shaft of that crank. So let me make it, I don't know, 1. Yeah. Okay. And this, I'll leave it as a whole. Okay. This is going to be bad look, but that's fine. All right. Save everything. And let's start the process. First thing we're going to do is anchor the panel, the triangular panel here. And let me move these apart so that we can see what we're doing. So translate it in the direction X. It's not moving. Oh no, no constraint. Translate in direction X, and this guy there, and this guy, we should be okay. All right, good. Let's put the hole in there now. The pipe in there, can you, well, you see, the pipe in there can be cylindrical or it can be prismatic. Which one depends on what you do with the rest of the stuff. Okay, so let me for now make it prismatic. Okay, because there are different ways these problems can. Your joints may be different from mine, but still it works. Okay, so coincidence between the axis of the shaft and this axis. Okay, and because I want it to be prismatic, I'll make a coincidence between the plane of the vertical plane of the gray plate and vertical plane of the shaft. Okay, shaft meaning the pipe. So coincidence, I think this is for the first part, the gray piece, and this is for the pipe. Is it? I don't know. Cancel that. I can't remember. Is that the pipe or something else? Let's try it. The wheel. Oh, this is the wheel. That was wrong. Try it again. Coincidence between this vertical plane, that's for the, you can see that's for the, that is for the gray piece, and the pipe, which was right here. Yep, right. See, it was so easy. I picked this one. That's the wrong one, of course. Pipe. That's going to become a prismatic. If I update, it's going to go jump there, and it's going to be going, back and forth. Now, as far as that blue piece attached to the pipe, there's two ways you can go. One is you can use this paper clip and basically attach that to the pipe as a paper clip, means it becomes essentially a single part and later becomes a rigid joint. That's one way of doing it. Let me go that route. Let me do it like that. So let me bring first of all this and put it on the pipe. So coincidence between the axis here and the axis of the pipe, and update. Okay, and then move it to a location that I like. So translate this thing in the Y direction, right there. Okay, say okay. Now if I use this paper clip between the pipe and this piece, later on this paper clip becomes a rigid joint, and that's really what I want. So fix together this and that. Very good. Okay. How about doing this crank now? So coincidence between the axis of this and the axis of the hole, okay, and coincidence between the face, this back face of this, and this, okay, update. All right, I don't like the way it looks like, so let me turn it around. Is it this one? Yep, flip. Okay, good, good. Yeah. Now, I told you I may not like the way these things look like. Like this is kind of interfering with that. As a mechanism, it doesn't matter. But in real life, that can happen. So I can go to this. I can go to that. It was a multi-pad, remember? So was it this? Nope. This? Nope. That. Okay. I'll make it 0.1. Just so that it looks nicer. Oh my God. Oh, that's okay. That's because of this fellow. Okay, you have to make this thing. Yeah. So that's easy. That is easy. Oh, wait a minute. Oh, maybe this, yeah, this one. Is that an, oh yeah, maybe when I update it, it's going to look okay. Yeah, let's go back, update, it's going to stick to that. Yeah, okay, so there is a kind of a gap there. We can see this. All right, let's put the wheel in there. So let's put the wheel on that face. So coincidence between, where is that wheel? Okay, okay, okay. This face and that face. Let's see when we update how it looks like. Where is it? I think they are coincident. Yeah. Okay, let's bring it closer so that we can see what's going on. Translate in direction Y. See where we are. Okay. That's fine for now. Okay. So I want to put this on that face because if you're going to do a roll curve joint, these faces must actually either this or yeah. So let me actually, before I do that, let me bring this thing, make it coincident with that face. So coincidence between this face and that face. Okay. So this last one probably won't let you do that. This one probably I have to get delete and now update. Yep. Okay. And I want to bring that thing and put it on that face. So contact, we have done this thing several times before, this and that. Say okay and update there. Okay. Good. And I told you in principle, this wheel is supposed to fit somehow with the shaft in that. I didn't make the shaft, but since I know the kind of joint that I want, I'm going to cheat. I'm going to say no problem. Uh, this axis, this axis, this is a bad drawing, but under the circumstances, I'll take it. Let's see, what are we doing here? Okay, good. Now, let's first of all see if save it. Before you do anything else, save it. Okay, so let's see. Keep all the constraints active and rotate about, for example, this shaft. Okay, let's see. I'm going to take the crank and turn it. Yeah, okay, it is going to work. All right. So this is not the mechanism. It is just the constraints that hopefully will give us all. It won't give us all the joints because roll curve joint cannot be done with the magic wand. You know that, or with the contact. You cannot do it a roll curve joint with just that contact that I did. The purpose of contact is to make sure that it sits on that plane so that these curves are tangent to each other. So let's go to the digital mock-up. Get the magic wand out. Auto create. Now I don't know. I know that we have a prismatic. We have two cylindrical probably. Let's see. One rigid. Yeah. So let's do the cheap way. Do it the cheap way. Just do the roll curve. See whether it takes care of the problem or not. Roll curve between this circle and that. And I'm praying that this becomes one so that I don't have to do any more work for you. Yeah. That's okay. No problem. a roll curve, make it, actually, I didn't want that. I want to make the, that's okay, there's no problem. But the Revolut one, the one with the crank and the wall, I want to make it angle driven because it's attached to a motor, right? So gray and crank. This one, I want to make it angle driven, attached to a motor. Let's see what happens here. All right. And first try it manually. It should work. Yeah, good, good. And simulate it. All the way to the end. Insert, rewind, rewind, and play it with anything less other than one. Okay, play. Yeah, that's the way it is. There's no physics here, just a cartoon basically. But the physics can be put into it later, and I'm not asking you to do that. Okay, there's no physics here. Okay, folks. Oh, it took half an hour. All right. Oh, you have 5 days, right? Any questions? Okay, no questions. We move on to the next problem. I want to finish this thing quickly so I can go and watch the rest of the soccer game. Where is this? Okay. This is like a garage door, you know. First of all, sure, I can make 4, but I'm out of time right now. Out of time means I want to go, but I'll make 3. How about that? If you have 4, you do exactly the same thing. And then this piece on this side is totally useless. You know, I can make a dummy piece here, and you look at this thing, as long as these fold against that path, you think that it also folds again. So what I'm going to do, I'm going to make this, just one of them. And just to make it look good, I'll mirror it on this side. But when it comes to using the joint, I don't need this. All I need is this left side. Okay, and I'm not going to do 4. I'm going to do 3. Okay. So let's go ahead here. On the test, you do 4. Save it. File. Say management. Save as. I think this is the right folder, August 6. Yep. So let's call it product 2. How about that? Product 2. Okay. Okay, let's insert the track. Insert. New part in there. This is going to be my track. Right click properties. Track. And track. Okay, so let's make it. On this vertical, well, first of all, let's go to part design. Part design. On this face. I'm wasting time here. I can draw a rough sketch and then clean it up. Okay, that's good. Exit. Pad it. Okay, 0.4. Here we are. Now, I want another one on this side because this was not drawn in a good place. What I can do is I can do a pattern here, linear pattern. So instances is 2, spacing I'll make it I don't know 10 inches. I want to pattern this and direction. Wait a minute. First direction, yeah, the first direction. Oh, wrong direction. Oh God. Okay, so this is the wrong direction. So cancel. I want it in this direction. Cancel. Let's try it one more time. Oh, I wanted the second direction. That's probably what it was. So let's make it 10 inches. Current solid. No, it's this. And reference is that. Is this first direction? Try it one more time. If not, I'm going to give up. First direction, reference element. Let me see. Okay, you want to say something? Say it. If not, I'm
Hello,
going to give up.
Professor.
Yes.
Is it possible for us to select a YZ plan as a reference?
Well, that's a good idea. Let's try it. So first direction, I'll make it 10 inches. Yeah, I think that's you're right. I was picking the wrong thing. Why is that? Ah, thank you. Excellent. This is totally useless, right? It's just going to sit there. So that's fine. No problem. Thank you. So let's save this. File save management. Because I created my part. Save as. It's in that folder. Product 2, right? Yeah. Okay. Good. Now, I'm going to insert the second part, and I'm going to repeatedly use it. There are three of them, right? And they're identical. So I'm going to make one and then use it repeatedly. So what is that? Insert, new part. Where are we? Oh, we have to be assembly design, right? Insert, new part. I'll call it panel. Right-click properties, panel, and panel. Okay. Let's make it. All it is a box, basically. So on a convenient plane, on that plane, I'll use a sketch. Yeah, something like this. Okay. Exit. Add it. All the way to this guy so that you have the illusion that really up to, I guess next. No, up to plane, this plane. Did what? Yep. You get the illusion that something is happening on the other side. Okay, good. And let's save this thing. So we go up here, save it. Very good. And now that we saved it, we can insert existing copies, insert existing components right there, or you can do copy and paste. Let's stop. August 6. Is this yours? Yeah, that's yours. Okay. Oh, where is that? No, not track, panel. Oh, right there, right there. Right there. You're going to sit on top of the other one. Let's do another one. Insert existing component in there. Another panel. Okay, good. So let's go ahead and separate them from each other. Where is this? Translate in the direction Z. Okay. Okay, so first thing I'm going to do is to anchor this track. Okay, good. Now, I want to put one of these panels on this track, so let me move these things. Translate, direction X. Closer, okay, good. I want to bring it up. So coincidence between, for example, this guy and that guy. Update, and the only reason I did this, I wanted to bring it up. That's it. There was no other reason. Okay, good. So let me also, I'll delete this. I'll delete this in a minute, okay? Also make it, let me delete this. Actually, I want to do it like that. I want to put this point on that curve. Okay, so let's see now. Let me first rotate it about that guy. Cancel. Rotate it about this. Okay, good. I want this point to be on that curve, and it is on that curve, and it is. And I want this point also to be on that curve. So coincidence between this point and this. Let me see. Undo. There was another constraint here. That's why it's not doing it. Delete this. Coincidence between. Actually, let me see. For example, yeah. Let's do it like this. This face and that face. Now both of them are going to be there. Yeah, good. And I want to do the same thing with the other guys. I want to bring this and put it next to that. So coincidence between this edge and that edge. Okay, is it there? Yep. And I want to, let me see for a second. Yeah. So let me delete these things. I'm going to rotate this about that hinge. You know, making this okay. What I should have done was yeah. Should have done this thing a different way. So in the direction X, let me translate this in direction X. Okay, and then make this edge coincident with that edge. Okay, and then rotate about this. That's what I wanted to do. Okay, and I want to put this point on that. Okay, now the only thing is that I don't want any of these things to move. Okay, so why don't I do the following? Why don't I make a coincidence between this plane and that plane? Hopefully that is not going to interfere with anything else. Okay, it's already coincident. Very good. So coincidence between this point and okay. The problem is that if this is an edge, no problem. I can take it. See that? This is an edge. I can take it. But because this is not an edge, it's part of this curved surface. Okay. When I try to select that edge, what happens is that it's going to select the axis of that. So here's what I'm going to do. If I had thought about this thing more carefully, I would have done this thing differently. So here, first of all, let's save this. We will go overboard. Okay. I want to extract this curve on the boundary. See that? This curve on the boundary and this curve on the boundary and the different ways of doing it. But here's the way I'm going to do that. I'm going to go to this part. There's different ways of doing what I'm trying to achieve, but I'm going to go to the track. I'm going to go to the sketch. Right, no, I'm going to go to the track. I did. So coincidence, no. Go to the generative shape design. Don't get the impression that you have to do these things. Depending on how you approach the problem. You started bad, you're going to end up doing these things. And I'm going to extract this edge and that edge. I guess you either do it at the same time. Here, control this, control that. Okay, extract. Good. Now I can do what I was planning before. So go back to the assembly design. Remember, I was trying to put this point. I was trying to put this point on that edge. I couldn't do that. Now I can do it. This point. Oh. Okay. No problem. Looks like this is putting this thing there. Let's do the following. I don't like what I'm doing, but let's try it. So create a, I know what, cancel. I have a better solution for you. This is fine. There's nothing wrong with it. Let me go ahead and drag this thing to the left. Okay. First of all, we're going to make this thing a little bit shorter. Okay. So let's go to the panel, the very first one that I did. Okay. I'm going to make this thing a little bit shorter. Yeah, the reason I put a dimension there because this was a copy of that. So let me make this thing, I don't know, 0.5. Okay, good. Exit. All right, good. So I'm going to drag all of these to the left a little bit. So translate this guy in the direction X. Actually cancel that. Do it again. Translate. Keep the constraint. and in the direction X. All right, very good. Now I can bring this point and put it on that. Okay, so coincidence, I hope. Update, very good. Do the same thing for the other one. So let's drag this thing here. Okay, too much. Drag this thing here. Okay, make a coincidence between this edge and that edge. Update, and make a coincidence between this point and that point. Undo. Turn it around a little bit. I want to go in the other direction. Oh, wait a minute. What is this? Did I make that? Let me delete this. Okay. Can I turn this thing about that? Yeah. Coincidence between this point and this. Update. Okay, very good. Now, one other thing I'm going to do. Remember I extracted these. Okay. I don't know whether they're joined because let's go ahead and join this. So let's go back to this sketch or this thing that I extracted and join these three. This and that and that. Okay, very good. Back to assembly design. Okay, so here's the situation. Definitely, you know that these are going to be, there's going to be a point curve, point curve, point curve, and point curve. Okay, definitely that. Why don't we actually create our joints manually instead of using the magic wand? Because there is really not much that you can use with the magic wand here because these are all point curves. Okay, so the only thing that you with the magic wand, make sure that these stay on that same plane, planar joint. That you can do it. But that being the case, let's go ahead and do this thing manually. So we go to the digital markup. Get the magic wand out, but there is of course nothing. Did I anchor? Yeah, there's nothing that's going to. Even the stuff that's going to get generated, I have to delete it. See, there's 5 joints that are going to be generated. I'm going to delete them. Okay, those joints are totally nonsense. Maybe totally nonsense. Yeah, so let's delete all of these. Delete. Don't delete the children in case I need them. Delete. And delete. Okay, here's the situation. Well, first of all, let's do our point curve joint. So point curve. Where's the point curve? Point curve joint. Okay. The curve is this. One point is that. Okay, so we hide this, hide the curve. There. That's one of my point curve joints. Okay. Now let's do another one between this point and the same curve. Another one, point curve joint. The curve is the one that I hit right there. Let me bring it in the front so that you can see it. The curve is still this. The point is that point, which is, for example, from that block. So just to be on the safe side, I'm going to hide this. I'm going to hide that. Oh, the problem with bringing existing component is exactly that. In other words, when you hide, everything is going. If you had copied it, that would not have happened. Okay, so I want to select this point. Okay, so I'll take my chances. It doesn't matter. Right there. Okay. Let's bring these things in front. See, this is the problem with using existing component. When you hide something or when you cut something, the other ones are going to get cut too. Let's do another one for this. So coincidence, a point curve. Between that curve, you know, maybe I should select it from the tree instead. Here, this joint, that's my curve. And the point, I'll do this. Now, I don't know, this one may be from the left block or maybe from the right block. It probably doesn't matter. It doesn't matter. And another one between that joint that I had and this point. Okay, good. Now, these are cylindrical joints, okay, because these are hinged together. So coincidence, not coincidence, cylindrical joint. Now, the problem is which one, see, they're sitting on top of each other and hiding, unfortunately. Okay, you know what we can do? We can do the following. Separate these apart temporarily. Let's go to separate these apart. Maybe the best thing to do is to go to the assembly design. Temporarily, we're going to separate them. Don't use the constraint. Separate them in the direction X, this and that. Say OK. Go back to the DMU. Create a cylindrical joint between this edge and that edge. Gee, I should have done it. Okay, now I'm going to have to separate these two again. Oh my God, I was hoping to do this thing faster. So, okay. So, go back to DMU, cylindrical between this and that. Okay. The final thing that you have to do is to make sure that these are all going to stay in the same plane. So you need to create a planar joint. Let's do the planar. Where's the planar? Planar joint between this plane and one of these. Right click properties and one of these. That's okay, no problem. Let's see what kind of joint you have. Degree of freedom is 1. Excellent. Let's make this in one of these point driven, length driven. What? Why are they sitting on top of each other? Oh no, I thought they were sitting on top of each other. God. Okay, check it out. You better go around it. You better go around the bend. If it doesn't, I'm going to stop it, and I'm going to hopefully do a better job with the second lab, and then post that one. How about that? Let's check it. Ooh, very good. I don't have to do that. I think the soccer game must be, second half must have started. Are there any questions? Is this the type of thing that you should be able to do? Of course it is. Of course it is. That's why you have 5 days. Yeah? Okay, folks. So I'm going to stop the recording here. The GAs are going to be around. And let's see. After today, if you want to talk to me, send me an email. All right? And yeah, you're responsible for everything. Take care. Bye.